This is kind of an interesting problem. We don't need to use derivatives or anything like that. We just need to look at the function. This is f of x, and we're trying to figure out what the minimum value is and what the maximum values are. And so we see that we have a maximum, let's start with a minimum. We have an absolute minimum of negative 1 at x equals 1, and then the maximum value of, right up here, and that's 2. I guess you can't really see it, but assume that there's 1 and there's 2. So a maximum value of 2 at x equals negative 2. That's it. That's it. For problem number 106, this is the typical problem here in which we have to find the first derivative and then the second derivative to determine what f is doing. Now, we already know a little bit about this. I mean, we could find the inflection point, and we could find the maxes and the mins just by understanding that the graph will look something like that. We know it's negative x to the fourth, so we know that the ends of the graph are going to go down. Now, it could go up like this. It could go up and then come down like that. So one of these three is going to be what this graph looks like. So we can be rest assured that it's going to be increasing first and decreasing last regardless. So let's see if we can figure this out using some calculus. Y prime is negative 4x to the third plus 36x, and y prime equals 0 when this function equals 0. So if we factor out a negative 4x, then we're left with x squared minus 9, and so we get x equals negative 3, 0, and positive 3. And so then we know that y prime is going to be positive on this first interval. We know that for sure. And then what happens in between negative 3 and 0? Well, let's pick a test value of negative 1. That's going to make this first factor here, negative 4 times negative 1 is positive. Negative 1 minus 9 is negative. Okay, so we've got negative in between negative 3 and 0. Then when we pick a test value of 1, we get negative 4 times 1 is negative, times 1 minus 9, so 1 squared minus 9, that's also negative. And so y prime is positive on that interval, and then from 3 to infinity, we can see that, let's see here, let me erase that. This is positive here. From 3 to infinity, if we plug in 4, let's say, we get a negative times a positive, so we get a negative again. Okay, and so it goes up, then comes down, then goes up, and then goes down. Interesting. So I thought it would actually be one of these guys, but it's not, based on our analysis. So the graph looks like that. So we know that it's increasing, and so we can fill in these details over here, increasing from negative infinity all the way to negative 3, negative infinity to negative 3. Okay, it's also increasing in between 0 and 3, 0 and 3, decreasing then between negative 3 and 0, so negative 3 and 0, and also decreasing then from 3 to infinity. So we have that. Now that also tells us that we have a max. So when f of x increases then decreases, we have a max value at x equals negative 3. Okay, at x equals negative 3 and also 3. Okay, because f goes up and then down. And then we have a minimum value at x equals 0. Okay, well, when x equals 0, we know that y equals 11. And then when x equals 3 or negative 3, f of x equals 92. I didn't write that very well. 92. So when you replace x with 3 or negative 3, you can see that we get 92. And then what else do we need here? Concave up and concave down. Yeah, I can use this space right above the problem here to find y double prime. So let's do that. Y double prime is equal to negative 12x squared, negative 12x squared plus 36. Well, what we want to know is when y double prime is equal to 0. Y double prime is equal to 0. when 12x squared equals 36. In other words, when x squared is equal to 36 divided by 12 is 3, so when x equals plus or minus radical 3. Okay, well we know what the shape of the graph is, so we know we have an inflection point right here, so it's concave down, and then right here as well, so it's concave down, then concave up, then concave down. So we have two inflection points. We don't even need a second derivative test because we already do know the shape of the graph. So it's concave up in between the two inflection points, and so it's concave up in between negative radical 3 and radical 3. Okay, that's where where f is concave. I don't know what I just said, but what I meant was that f is concave up on the interval from negative radical 3 all the way to positive radical 3, and f is concave down, so that's part D, concave down from negative infinity to negative radical 3, and then also concave down from negative, sorry, not from negative radical 3, but from radical 3 all the way to infinity. Okay, and then the very last thing, we need to know what the inflection points are, and the inflection points are when x is equal to positive or negative radical 3. So both positive and negative radical 3 are going to yield the same y value because x is being raised to the fourth and the second power. And so when x is equal to positive or negative radical 3, we get 164, and all you have to do is replace x with either plus or minus radical 3, and you're going to get 164. So those are the two inflection points. We see all the rest of that information there, and then we will pick up problem 107 in the next video.